It's not that difficult. It's fairly simple. Today we're dealing with the fundamental counting principle. Okay. So a lot of what you do when you're doing statistics or probability or other things, a lot of math is counting. How do we count? And when you're a little kid, it's easy. 1, 2, 3, 4. How many do you have? It can get a little more difficult as time goes on. Yes. Okay. So we have a couple of things. First of all, factorials. And factorials are on your calculators. Okay, so a factorial is represented by an exclamation mark. It means multiplication. For example, 5 followed by an exclamation mark is not 5. Does not mean we say the word 5 with emphasis. 5 factorial is 5 times 4 times 3 times 2 times 1, or 120. Sorry, I had to remember what the number was off the top of my head. Okay, that's what a factorial means. You take that number times 1 less times 1 less times 1 less times 1 less until you get down to 1. So 8 factorial will be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And they can get pretty big pretty fast. Okay. There is on your calculators a way to do factorials. You're not going to have to do anything that big, probably, so it's not that big a deal. There will be a way to do it. Okay. Now, the big thing we're going to be talking about today, though, is the fundamental counting principle. So, fundamental counting principle, if event number 1, the thing that I want can occur so many ways, and then event number 2, the second thing I'm doing, can happen so many ways. To find out how many ways together, I just multiply it. The fundamental counting principle is also known as the Chinese menu theorem. Go to a Chinese restaurant and have their lunch special. 1 from column A, 1 from column B, and 1 from column C. How many times can I eat there without having the same meal twice? You take how many choices there are in column A, times how many choices there are in column B, times how many choices there are in column C. You multiply those 3 numbers, that's how many times you can go there without having the exact same meal twice. Okay, that's the fundamental counting principle. You take how many times the first thing can happen, times how many ways the second thing, times how many ways the third thing, and so on. Okay? If I have 5 shirts and 3 pairs of pants, how many outfits can I wear with those 2 things? 5 times 3, 15 times before I wear the same outfit twice. Okay, that's not, of course, counting for fashion sense, but you get the idea. Okay, that's what the fundamental counting theorem is about, okay, or principle. It's how to count things. How many ways can something happen? Okay, so turn it over. So, and you may want calculators for some of these numbers because they can get large in a hurry. Okay, I'm going to get my calculator out. Okay, so how many ways can I have a California license plate assuming 1 number followed by 3 letters followed by 3 numbers? Now, we are not going to limit ourselves the way that the state actually limits you. For one thing, you're not allowed to have certain letters. You're not allowed to have I.
Why?
What does it look like? It looks like a 1. You're not allowed to have an O or a Q because they look like 0. Okay, so you're not allowed to have those in your license plate. Okay, so you have choices. Now we're going to ignore those rules for today. Yeah, you have a hard nail too. It's kind of we're going to ignore all that crap too. So, California license plate assuming one number followed by 3 letters followed by 3 numbers. So I have 7 spaces to fill. 1, 2, 3, 4, 5, 6, 7. Now, like I said, I'm not going to limit myself. No zeros, no O's. I'm not going to do any of that. We're going to just assume that everything's available and none of the special symbols like hearts and little hands and crap like that. Okay? So, one number. How many choices do I have for the first number? What possibilities are there? Well, there's 1, right? 2, 3, 4, 5, 6, 7, 8, 9, and 0. So how many choices do I have for that first number? I have 10 choices. That first spot, I have 10 choices. Okay. Followed by 3 letters. So my next one, I have a letter. How many letters are there in the alphabet? 26. So how many choices do I have? 26. Okay. Now, in a license, can I have the same letter more than once? Yeah, you can. So how many choices do I have for the next one? 26, because I've got 26 letters in the alphabet. So I have 26 choices for the next one. How many choices do I have for the next one? 26, because it's 3 letters. Okay, sorry, 26. Okay, so followed by 3 numbers. So the next one is a number. How many choices do I have there? I have 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10. And the next one? And the next one? 10. So how many combinations? You multiply all of these together. And use your calculator. You're going to want to use calculators for this until almost 1, 7, 5, 7, 6, 1, 2, 3, 4 zeros. Yeah. 175,760,000. It's a lot of license plates. Okay. Okay, Ryan, chill. Chill. So, that's how many license plates we can have. So next one, 5-digit even numbers. Same idea. So I have a 5-digit number. 10,298. 14,352. Okay, 5-digit number. That's what we're looking at, something along those lines. So I have 5 digits, 1, 2, 3, 4, 5. Now, the first one, my first number that I have, like I said, it's a 10-digit number. 20,398, 99,422. How many choices do I have for the first number in there, the largest number? Nope, it's not 10. Because what can't I have? I can't have a 0 in the front. Because if I have a 0 in the front, it's no longer a 5-digit number, it's a 4-digit number. So I can't add 0, so I have 9 for the first one. Okay. Because we don't go 0, 1,000, right? If it's 1,000, that's a 4-digit number. You don't say 0, 1,000. So 9 choices for the first number. It cannot be 0, but it can be anything else. How many for the next one? 10, because I can have all 10 choices. I can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can have 10 choices here. And how many for the next one? 10. Okay. And then the next one? And then the last one. Why? It can only be even numbers, so we have 5 choices. So for it to be an even number, what does it have to do? It has to end in 0, 2, 4, 6, or 8. So I have 5 choices. One of those 5 numbers has to be my last number to make it even. If it's something other than those, it's not even. So how many are there? You multiply those together. Yeah. 5 times 9 is 45 with 3 zeros. So it's how many ways the first one, times how many of the second, times how many of the third. Sometimes it's a little bit bigger than others. Sometimes it's a little more complicated than others. So phone numbers with the 622 prefix. So how does a phone number work? Well, first you have the area code, right? 3-digit number for the area code. No, only that's just for dialing purposes. Technically, if they're in the same area code, you didn't used to, but that's because cell phones are stupid and screwed everything up. Okay. So you have your area code: 530-707-212. 805. That's what I grew up with.
999.
Yeah. Yeah, that's just reasonable. Yeah. Okay. So area code narrows it down to a state or a portion of a state. You'll never have an area code that covers more than one state. But some states, because the population is so small, they have one area code for the whole state. Hawaii. One area code for the entire state of Hawaii. It's an island you're on. So, and then you have the 3-digit prefix. Now, it used to be, cell phones have kind of messed up a little bit on this one, but it used to be your prefix was where you lived, what city you lived in. So like Placerville had like 4 or 5 3-digit prefixes. If it was, so when I lived up in Garden Valley, 333 was always Georgetown or Garden Valley. Okay, if your first 3 numbers were 3, in fact, almost everybody for the longest time, if you lived in Georgetown, the first 3 numbers of your phone number was 333 for everybody. Okay, then eventually it got big enough they needed to add it to make it 331. So they added another one. When I grew up, there was 5 prefixes for my town that I lived in. First 3 digits was one of 5 choices. Okay, so your prefix, that's what we're talking about here, is 622. How many 622 numbers are there? Well, then I have the 4 that are left. Okay. So, how many choices do I have for my next number? I have 10 because there's nothing that cannot be a number for a phone number. There are in the prefixes and the area codes, but not for anything after that. So I have 10 choices here. Can I have the same number more than once? Yeah, they could all be all 4 the same. That's no problem. So I could have 10 here, and 10 here, and 10 here, because they could all be the same. Mine as a kid growing up, I had 3 numbers that made up my entire phone number. 4s, 8s, and 6s. My apologies. Okay, so I multiply it out, means that I have 10,000 possible phone numbers that start with 622. This is why when I lived up on the hill, Georgetown area, 333, 10,000 people had to live there and get a phone number before you had to add another prefix. Yeah, the phone company could give out 10,000 numbers before they had to add another prefix to it. Okay. That's why my town growing up had 4 prefixes, because the population was right around 35,000. You're not going to have more phone numbers than that. Okay. Now the next one is interesting. Okay, so I got 30 students in the class. I'm making up a seating chart. So 30 kids. How many choices do I have to put in this first seat? I got 30 because I got 30 kids to choose from. Pulling names randomly out of a hat. I got 30 names to choose from. So I got 30 that can go here. How many can go here? I've got 29 choices because one kid's already taken. And then how many would I have here? 28, 27, 26, 25. So just that first row, 30 kids in the first seat, 29 kids in the next one, 28, 27, 26, 25. So if I have 30 kids in class when I'm making the seating charts, I have how many possibilities for that first row? It's a big number, isn't it? 427,518,000. That's just the first row. That's how many different possible first rows I could have. And then if I start counting up all the rest of the possibilities, it gets pretty big in a hurry. It doesn't matter how many seating charts I make up, how many times I do this, I'll still have two kids that cannot shut up when they're sitting next to each other, and they will always end up next to each other. And I get told, put them in the four corners. Well, I got more than 4 kids. I can't separate them. I need more than 4 corners. Fundamental counting principle. I like it. It's easy. How many ways? Times how many ways? Times how many ways? Times how many ways? It's a great way of counting things.